We already discussed loose coupling in the software components section when we talked about the need to loose couple classes using dependency injection so that changes in one class won't necessarily affect other classes. This concept is also true for system architecture, although on another scale. When talking about loose coupling in system architecture, we talk about making sure the various components or services are not strongly tied to other components. The reasoning for this is, again, quite similar to the loose coupling inside components. If services will be coupled to other services, then every time a service is changed, and in modern systems this happens a lot, this change might affect other services that use it. By loosely coupling the services, we ensure the independence of each of the services and make sure they can be modified with minimal impact on other services, if at all. This will make our system much more flexible and, of course, very easy to maintain. Now, you might have a good question here. Since different services run in different processes and do not share the same code, what's the point of loose coupling? It's not that when a single class is changed in service A, it will affect other classes in service B. Well, that's indeed a good question. In fact, loose coupling in services or components has other meaning than loose coupling inside components. In general, loose coupling in services means that the fact that a service is implemented in a specific platform or exposes specific API will not force other services to use the same platform. In addition, loose coupling also means that changes in the service API, such as its URL or its parameters, will have minimal to no effect on the calling services. Let's look at an example. Say we have a service that exposes stock quotes. The service is Java-based. Now let's say we need another service that manages portfolios for customers. Naturally, this service will have to query the stock quote service for some data. The stock service exposes its API as a Java RMI, remote method invocation. This is a simple, performant, and effective method for executing API on remote objects. The problem is, using RMI, the calling service, which is the portfolio service, must also be developed in Java. This is a limitation of Java RMI. So in this example, we created a strong coupling. The implementation of the stock service forced the developers to use Java also for the portfolio service. Let's look at another, more modern example. The stock services developers understood that RMI is not the right solution for modern apps and switched to REST API, which is a de facto standard for API nowadays. Another service, responsible for creating investing recommendation, was built in Python and is querying the stocks service. This time, the querying is done by making a REST call to the stocks service. Note that the service is implemented in Python this time, and there is no problem with that. Everything is good for a few months, and then the stocks service has to be moved to another URL for some IT-related reasons. What happens now is that because the stocks service URL has changed, all the services working with it has to change their code to point to the new URL. That means one thing. There is a strong coupling between the services, even though the API itself is exposed using standard platform-agnostic REST API. To make it more clear, let's talk about a full-blown application. This application will probably have at least 6 services. Naturally, they are going to communicate with each other. Now, if they communicate directly, like this, we will have what is known as the spider web. I guess you can understand why. Now imagine what will happen if a single service will change its URL. See how many services will be affected? If your services map looks like a spider web, be ready for a nasty surprise when even one of the URL is changed. The spider web is a sure sign of a strong coupling system. Now, there are a couple of ways to solve this coupling. 1. Build a Yellow Pages directory for the service. Whenever a service needs to communicate with other service, it asks the directory for the URL of the service it wants to access and uses the URL it gets. This way, the URL is not hard-coded into the service, and when it changes, the change affects only a single service, the directory. In this solution, there is only a single URL the services need to know, the directories. And so, if it changes, which won't happen frequently, the change will be limited to a single URL only. You can develop one of your own, and there are some great tools that do just that, such as Consul. Another way is to build a middleman or gateway. In this scenario, the service accesses the middleman and asks it to go to the stock service and make a query. The middleman holds an internal mapping table which maps tasks to URLs, and so it knows which URL to access in order to fulfill the task given by the calling service. The calling service has no idea what the URL of the stock service is, or even if there is a stock service. All it knows is that he asked the middleman to do something, and it was done. It doesn't care how, where, and by whom. In this solution also, there is only a single URL the service needs to be aware of, the middleman's, so changes will be limited to this single URL. Now, it doesn't really matter which solution you pick, they are both good. You will also see variations of those two, and sometimes it might be even a good idea to implement both. But the important part is that you will better avoid strong coupling by using at least one of them. It's always a good idea to keep your services as loosely coupled as possible, thus making your system much more flexible and maintainable.